Okay, so now we're in section 10.2, and I want to go over some of the examples with you with a calculator. In 1997, 46% of Americans said they did not trust the media when it comes to reporting the news fully, accurately, and fairly. In a 2007 poll of 1,010 random adults nationwide, 525 stated they did not trust the media. At the alpha equals 0.05 level of significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? So first it says to check the requirements. So if we scroll back in our notes a little bit, we will see the requirements. Okay, so the requirements are a simple random sample has been obtained, n times p naught times 1 minus p naught is greater than or equal to 10, and the values are independent. Okay, so let's go ahead and take a look at what's given. So the first one we'll do is n times p naught times 1 minus p naught. That needs to be greater than or equal to 10. This is really the only way to ensure that our sampling distribution of p hat is normal. So n is the sample size, which is 1,010. P naught is the previously accepted value of the proportion. So you can see that was given right away. That was 46%. So we'll write that as a decimal. And then times 1 minus 0.46. So let's get that value. 1,010 times 0.46 times 1 minus 0.46. Okay, so it's about 250, which is certainly greater than 10, so we're okay. One of the requirements was also that the sample needed to be random. It does state that there was randomness in the sampling method, so we're okay with that one. And then the last one was that the sampled values needed to be independent of one another. So specifically, the sample size needs to be less than 5% of the population. The population here is Americans. The sample size is 1,010. That is definitely less than 5% of Americans, so we're also okay with that one. So this means that all the requirements have been met. So we can go ahead and move on to part B, state the null and alternative hypotheses. So in our hypotheses, the parameter in question is P, the population proportion. So H naught, which is a statement of no change, would be that the population proportion is the same as it was in 1997, that the population proportion is still equal to 0.46. The alternative challenges that. So it says here, is there enough evidence to support that the percentage has increased? Sorry, that the percentage has increased. So that gives us our alternative hypothesis. The suspicion is that the proportion is now greater than 0.46. Okay, our evidence does support that, but is the evidence strong enough to reject the null hypothesis? Or could it just happen by chance? That is what the p-value is going to tell us. So we're going to go ahead and find the p-value, which is a probability. So in the calculator, we go to stat, arrow across the top to tests, and we want number 5 here, which is 1 prop z test. It stands for 1 proportion z test. The z refers to the standard normal distribution, which is what the probability is based upon. So we're going to go in there. It's asking for a few things. It's asking for P naught, which will be your proportion that's in your hypothesis, which is 0.46. It's asking for X, the number of individuals in the sample with the given characteristic. In this case, 525 people did not trust the media out of a sample size of 1,010. Now we select our appropriate inequality symbol. We have a greater than here in our alternative, so we want to choose the greater than hypothesis here. And you go to calculate and press enter. So this is giving us a few things. It's giving us a z-value. That is the z-score of our sample evidence, 3.8, which means that's 3.8 standard deviations above the mean, which is quite distant from the mean. This here is the most important thing. This is the p-value. So it's 1.3717, and then notice the e-4. The probability is so small that it is in scientific notation. So we're going to go ahead and write that in standard notation in our notes. It also tells us p hat. This is the value of our sample proportion, 0.5198. Notice that that is quite a bit higher than 0.46. And certainly it is supportive of H1, as it should be, and then it just restates the sample size. So let's go ahead and write down our p-value. So e-4 means move the decimal 4 places to the left. So we're going to have a 0.0001. So that's a very small probability indeed. So what we're going to say is, in interpretation, the probability that 525 out of 1,010 Americans do not trust the media, is 0.0001 under the assumption that 46% of Americans do not trust the media. So let's talk about this a little bit, about the p-value. The p-value is a probability. It is computed based upon the assumption that H0 is true. So if you had your normal distribution here, and you had your 0.46 in the middle, this sample proportion, which was about 0.5198, that would be way over here. So this p-value corresponds to this area. So if it were true that the actual parameter was 0.46, the probability of getting this sample result, 525 out of 1,010, the probability of that happening is extremely small. And in fact, it's so small it causes us to suspect that this is not true. That 0.46 is probably not the true value of the parameter. So that answers the question really for part D. Do we reject or fail to reject H0? Why? Well, in this particular question, the level of significance alpha was 0.05. All you need to do is compare p to alpha. In this case, p is less than alpha. The probability of getting these results is less than 0.05, which is the level of significance. So do we reject or fail to reject H0? We reject H0 because p is less than alpha. So anytime your p-value is less than alpha, which is the given level of significance, that is when you reject H0 because your sample evidence is so strong. So your conclusion will be there is sufficient evidence. There is sufficient evidence to conclude that the proportion of Americans who do not trust the media has increased. So when you state your conclusion, you always kind of restate what the alternative hypothesis was all about. Let's try one more. In 2000, 58% of females aged 15 years of age and older lived alone. A sociologist tests whether this percentage is different today by conducting a random sample of 500 females aged 15 years of old and older and finds that 285 are living alone. Okay, so once again, we've been given a predetermined value of population proportion. So instead of 58%, we'll use 0.58. The sociologist is wondering if it is different today. So she did not give an opinion as to whether or not it's gone up or down, just that she thinks it might be different. So that kind of points us to doing a two-tailed test. So H0 is always the statement of no change, right, that the proportion would still be 0.58. H1 is saying that, okay, it could be different. We don't know which direction it might have gone, but we're going to say P is not equal to 0.58. So let's go ahead and determine the p-value in the calculator. So we go into Stat, arrow across to Tests, and it's number 5, 1 prop Z test. All right, P0 is 0.58. The number of individuals with the given characteristic from the sample is 285 that live alone out of a sample size of 500. And this time we do want this not equal to hypothesis, this two-tailed test. We're going to calculate. Okay, so what we're getting is a few things. We got a z-score, we got a p-hat. The most important thing here is the p, the second one. That is our p-value. That's the probability that we want. So let's write this down. It's about 0.65. And as far as p-values go, that is pretty high. So let's take a look at part C. Perform the hypothesis test using the alpha equals 0.1 level of significance. Do we reject or fail to reject H0? Okay, so in this case, our p-value is greater than alpha, right? Alpha is 0.1, the p-value is quite a bit higher. In this case, we do not reject H0. Our sample evidence is not compelling. If H0 were true, it wouldn't be unusual to get a statistic such as this. So notice that p-hat is 0.57. That is not the same as 0.58. But what's happening here is that it's not different enough. It's not unusual to get this if this was actually the population proportion, okay? And we can see that because the p-value is so high. Let's go ahead and write down a conclusion. There is not sufficient evidence. There is not sufficient evidence to conclude that the proportion of women living alone has changed since 2000. And notice how carefully worded that is. There is not sufficient evidence because there is evidence, right? P-hat is not 0.58. P-hat is different from 0.58, but it's not different enough to cause us to reject H0. I want to show you one more thing in the calculator for this example. If you go back into your 1 prop Z test and you choose draw instead of calculate, it will show you the shaded area corresponding to this p-value. And so you'll see that it's a two-tailed test, meaning that evidence here or here could have made us question H0. The shaded area is quite large, meaning that the p-value is high, and that is why our results are not considered statistically significant. Okay, let's look at one more example. In an American Animal Hospital Association survey, 37% of respondents stated that they talked to their pets on the telephone. A veterinarian thought that percentage sounded a bit high, so he randomly selected 150 pet owners and discovered that 54 of them spoke to their pet on the telephone. Does the veterinarian have the right to be skeptical? Use the alpha equals 0.05 level of significance. Okay, so this one doesn't really go step by step for us. But what we can do is translate this veterinarian's cause into a hypothesis test. So the predetermined proportion of people who talk to their pets on the phone is given as 37%. So his null hypothesis would be that P is equal to 0.37. He thought it sounded a bit high, which means he's probably thinking that the proportion is actually less than 0.37. So that would be the alternative hypothesis. Now what we need to do is get a p-value and compare it to this level of significance alpha right here. Okay, so let's go to stat, test number 5, 1 prop z test. P naught is 0.37. That is the proportion in our hypotheses. X is 54 people that speak to their pet out of N 150 people that speak to their pet on the phone. And our alternative hypothesis is a less than, or a left-tailed test. And we'll go down to calculate. Okay, so we're getting a p-value. It's about 0.4 if I'm rounding this. So 0.4 is pretty high for a p-value. It certainly is higher than our level of significance here. So because p is greater than alpha, we would do not reject h naught. So the question here is, does the veterinarian have the right to be skeptical? And really, we would say no. Right? He did get a p hat of 0.36, which is less than 0.37, but it is not significantly less. And we can tell that because the p-value here is 0.4. If we take a look at the picture for this one, just go down here to draw. You can kind of see why it's called a left-tailed test. Our sample evidence occurs over here in the left tail. If it had been significant, we would see a very small shaded region, but a very large shaded region is here because our p-value is so high, and it gives us the z-score right here. It's about 0.25 standard deviations below the mean. It's nowhere near to being a statistically significant result.